to differentiate the sum of two functions, let's consider renaming the sum of these two functions k. To differentiate, one more time, going back to my limit of the difference quotient as my definition of the derivative function, there's my difference quotient inside the limit. However, going back again to the fact that you and I are such experts with our pre-calculus, I think another name for k is just this. Well, I guess that wasn't using pre-calculus yet, but here I will. This whole function, eval n x plus h, is a function whose output is the sum of the individual outputs for f and g, eval and that input. So, as I just stated, I can rewrite the output of this function as the sum of the outputs for f and g with the same input. I can play exactly the same game over here. Now allow me to rearrange my terms. If you allow me to interchange the second and third terms, here's what I get. Okay, everyone, I think I'm finished. Next, I'll talk my way through what's coming next, but let me not write. So next, rewrite this one single fraction as a sum of two fractions. Here's one, here's a second. That's just going back to how I add fractions in the backwards direction. Next, split the limit of sum up into the sum of two limits. However, the first limit is merely f prime of x. The second limit is merely g prime of x. So I think what you and I have just established is that to differentiate the sum of two functions, you simply get the sum of their individual derivatives. Subtraction works exactly the same way. The proof is almost identical to what I just gave you on the other side of the board. In other words, the derivative difference of two functions is a difference in their individual derivatives. So if you take a peek at my list so far on the right-hand side, everything is so nicely behaved. However, if this operation, addition, is multiplication or division, it's not the case that differentiation as a process distributes over the operation. So I'm afraid I'm going to have to look at the product and the ratio of two functions quite differently than I do in this very simplified list.